Every type of AI explained. Narrow AI is a type of artificial intelligence that is designed to do one specific job, and it usually does that job very well. In fact, most of the AI we use every day is narrow AI. You can find it in navigation apps, voice assistants like Siri, movie recommendation, online translators, and even email spam filters. However, narrow AI has a downside, so to speak. It can only perform the task it was trained for. If it were a human, narrow AI would be that one friend who can solve the most difficult math problems in minutes, but still needs help figuring out how to use the office printer. So, how does it work? Narrow AI recognizes patterns and follows the rules it has learned from large amounts of data. In fact, systems designed to do so can beat humans at complex games like chess or Go, or generate realistic conversations, even though they don't know what a game is in a human sense. Machine learning. In the time before AI, if you wanted a computer to do a task, you'd have to write rules. Machine learning flips that idea. Instead of hard coding rules, you feed the computer lots of data, like thousands of emails labeled spam or not spam, and it learns patterns on its own. Now, there are a few learning styles. In supervised learning, the data comes with correct answers, like labeled photos of cats and dogs. In unsupervised learning, the system looks for hidden structure without being told what's right. And in reinforcement learning, it learns by trial and error, similar to training a dog with rewards. Under the hood, most modern machine learning uses math models called neural networks, which are loosely inspired by how brains process information, just much simpler and very fast at pattern recognition. Once trained, these systems can even make predictions on data they've never seen before, like recognizing your voice, recommending movies, or translating languages. Deep learning. Deep learning AI is like machine learning's more intense, high-powered cousin. At its core, it uses something called neural networks, but instead of real neurons, you've got layers of mathematical nodes passing information forward. The deep part just means there are lots of these layers stacked on top of each other. The first layers might detect simple things, like edges in an image or basic word patterns in text. As you go deeper, the network starts combining those simple signals into more complex ideas, like recognizing a face, understanding sarcasm, or translating a full sentence. Deep learning models have skyrocketed in the last couple of years, as modern breakthroughs like chatbots, voice assistants, and image generators all rely on them. What makes it work is a training process called backpropagation. The model makes a guess, checks how wrong it was, and then slightly adjusts itself, millions or even billions of times, until it gets really good at the task. It's basically trial and error, but on an industrial scale powered by huge datasets and fast GPUs. Generative AI. Of course, there are types of artificial intelligence that don't just analyze or classify things. Generative AI, for example, actually creates new content. That could be text, images, music, video, or even code that didn't exist before. It works by learning patterns from massive amounts of data during training. For example, a text-based generative model reads tons of books, articles, and conversations to learn how language flows, how words tend to follow each other, what tone sounds natural, and how ideas are structured. Then, when you give it a prompt, it predicts what should come next, one piece at a time, while it also builds something new as it goes. Many modern generative systems use deep learning to help them figure out how things should be made. These are especially good at understanding context, which is why they can keep ideas flowing way better than a 3-year-old that keeps rambling about their favorite cartoon. And it's not just text. Image generators learn patterns from huge collections of visuals. So when you type something like a futuristic city at sunset, they will make you a unique one every single time. Conversational AI. Conversational AI focuses on one thing, talking with humans in a way that feels natural, helpful, and ideally, like you're not arguing with a broken vending machine. At its simplest, it's what powers chatbots, voice assistants, and systems like customer support bots. What many don't know, however, is that it's doing a surprising amount of work just to keep a conversation flowing. The thing is, when you type or speak, the system first tries to understand your intent. Are you asking a question, giving a command, joking, venting, or just saying hi because you're bored? Then it generates a response, and checks everything again before it writes the next one. Some systems even weigh the importance of earlier messages, so they can easily remember what matters and what doesn't. On top of that, safety and style filters often run in parallel, shaping tone, politeness, and what gets softened or refused. Basically, a conversational AI will pay more attention to how it talks to you than most people you know. Computer vision AI. In a way, computer vision AI is like giving machines a second set of eyes, but instead of actually seeing, those eyes are constantly calculating probability, comparing patterns, and slowly figuring out what's in front of them. At its core, this AI takes raw pixels and turns them into structured information. An image is first seen as a grid of numbers that represent brightness and color. From there, the system starts detecting patterns. Early layers detect simple things like edges, textures, and contrast. As the data moves deeper through the model, those simple signals get combined into more meaningful concepts. Eyes, wheels, buildings, faces, and eventually full scenes like a crowded street or a dog jumping through water. Most modern computer vision systems rely on deep learning, especially convolutional neural networks, better known as CNNs, though transformer-based models are becoming more common. These are trained on massive datasets containing millions of labeled images, which allow AI to learn what objects typically look like across different lighting, angles, and environments. And you'd be amazed at how many fields computer vision AI covers. It helps self-driving cars detect pedestrians and road signs, assists doctors in analyzing medical scans for early signs of disease, and even powers facial recognition systems. Speech AI. When you speak, your voice creates vibrations in the air. Speech AI systems capture those vibrations through a microphone and transform them into a digital signal, which is then broken down into tiny acoustic patterns. From there, the system tries to figure out what was said. These models learn the relationship between sounds, syllables, and words, even when speech is fast, accented, slurred, or noisy. Modern systems predict the most likely sentence based on context, which is why they can often correct themselves when audio is unclear. But speech AI is also about generating voice. Text-to-speech systems take written text and convert it into spoken language. Early versions sounded robotic and flat, but modern models can mimic natural rhythm, emphasis, and even emotional tone, making voices sound surprisingly human. It has challenges, sure. Background noise, overlapping speakers, and rare accents can throw it off. But that will probably be solved in a matter of years, if not months. Recommendation AI. Every time you see, "You might also like," "Recommended for you," or "Because you watched this," you're looking at recommendation AI in action. It works by analyzing patterns in your behavior and comparing them with millions of other users to find hidden similarities. At the core, it's trying to solve a simple problem. Given what we know about you and people like you, what is the most relevant thing to show next? Modern systems often combine this with finding items similar to what you already engaged with. And instead of just looking at obvious signals, recommendation AI picks up on subtle ones too, like how long you hovered over something, whether you paused a video, or even the order in which you consume content. All of this becomes part of a massive behavioral map that helps the system refine its predictions over time. Of course, there's a trade-off. Recommendation AI can be so good at predicting preferences that it gets you stuck with the same type of content over and over again. Still, with enough data, recommendation systems can spot patterns humans would never notice, like niche communities with shared tastes or unexpected links between different types of content. Multimodal AI. People, of course, use more than one sense in their day-to-day life. Similarly, instead of working with just one kind of input, multimodal AI combines multiple modalities of data. In other words, it can look at a picture, read a caption, or listen to a sound, and understand how all of them relate to each other in one unified context. Some models encode images into visual tokens, audio into spectrogram patterns, and text into language tokens, all of which are then processed together in a shared space. This allows for powerful capabilities, describing images in natural language, generating images from text, answering questions about videos, or even combining all three in real time. You see multimodal AI in tools that can explain diagrams, analyze charts, interpret photos, or respond to voice while also referencing visual context. But the market is expanding. This type of AI is also becoming a foundation for more general AI systems, meaning that the future is getting closer day by day. Agentic AI. Most AI you interact with is reactive. You ask, it responds, end of story. It's basically the digital equivalent of a really fast librarian who hands you exactly what you requested and then immediately goes back to staring into the void. Agentic AI, on the other hand, is what happens when that librarian decides they're also going to do the research, write the report, schedule the meeting, and possibly reorganize your entire life while they're at it. Instead of waiting for one prompt at a time, Agentic AI works toward goals. It's still powered by a language model, but now it's wrapped in a loop: plan, act, observe, adjust. It can also use tools such as search engines, code execution, and APIs. However, the very fact it can adjust also means it can get a bit overconfident. Sometimes it's as annoying as an assistant who insists it's just one more step away from solving the problem in your schedule for the 5th time in a row. Robotics AI. If most AI lives inside screens, robotics AI is what gives it a body. and suddenly everything gets more complicated because the real world is messy, unpredictable, and occasionally allergic to precision. This type of AI combines perception, planning, and control. First, the robot has to understand what's around it using sensors like cameras, LiDAR, infrared, or touch sensors. Then it interprets that data, figuring out things like that's a table, that's an obstacle, or that's a fragile object I probably shouldn't eat across the room. Finally, it decides how to move. Motors, arms, wheels, or legs translate those decisions into physical action. Unlike purely digital AI, robotics has to deal with physics in real time. Gravity doesn't negotiate, floors are not always flat, and objects have a frustrating habit of not behaving like training data. So modern robotics AI often use a mix of machine learning, classical control systems, and deep learning. Artificial general intelligence. Artificial general intelligence is still undeveloped, but when this finally happens, the world will suddenly look completely different. The thing is, while today's generative AI systems already feel a little general, they lack understanding and adaptability. AGI systems that are being built as we speak will be designed to build robust models of the world, update them through experience, and apply them across entirely new domains, all without retraining from scratch. So in a way, today's generative AI is like a very skilled improviser who has studied an enormous amount of material and can perform convincingly in almost any scene. On the other hand, AGI would be the one who understands the entire play, learns new roles, and adapts the script as reality changes around it.